Hi guys, today I'm going to walk through a different paper. This is the Unit 1 Paper 2 in Pure Mathematics, Algebra, Geometry, and Calculus. CAPE, C-A-P-E paper for the Caribbean examinations, and this is the most recent paper, May-June 2025. The time will be 2 hours and 30 minutes, and I'm going to walk through this paper under the real exam conditions as well. This paper is totally unseen. I've never touched this paper before. Okay, let's see how it goes. Let's get started. Okay, question 1. The function f(x) equals px cubed plus qx minus 6 has a factor of x plus 2, the remainder of minus 12 when divided by x minus 1. Show that p equals 1 and q equals minus 7. Well, when it says a factor of x plus 2, the critical value here is x equals minus 2. You just basically put x plus 2 to 0. You get x equals minus 2 there. So we do f minus 2 equals, so p minus 2 to the power of 3, basically just subbing in minus 2 to all the x's, plus q times minus 2 minus 6. We're going to put this equal to 0 because it's a factor, right? Okay, so that's minus 8p minus 2q minus 6 equals 0. And we're going to put that to equation 1. Okay, of course, we're going to need another one. Remainder of minus 12 when divided by x minus 1. So that's f1, right? The critical value there would be 1. So 1 to the 3 is 1, so that's p plus q minus 6 equals minus 12. And let's put that to equation 2. Let's see, so we're going to solve simultaneously. Well, let's multiply the equation 2 by 2. So we're going to get 2p plus 2q minus 12 equals minus 24. And I call that equation 3. Now let's see, equation 1 and equation 3 can be added, right? So I add the two equations together. And then what do I get here? Well, minus 8p plus 2p, I get minus 6p. Minus 2q plus 2q go away. And then I get minus 18 here equals minus 24. Well, if you subtract by minus 18 on both sides, I'm going to get minus 6 here, and p would be equal to 1 indeed. If we plug that back into, let's say, the simplest equation, maybe equation 2, I'm going to get 1 plus q minus 6 equals minus 12. So that will make q equals minus 6 move there. 1 minus 6, we get minus 5. Minus 5, subtract the other side, I get minus 7. Yep. So this is as required. Yeah. Next, part II here, determine the other two factors of f, right? So we're going to go back to take this. So fx is just, if we plug in p and q, just what we just found, then we get what? X cubed minus 7x minus 6, yeah? And then we're going to find the other factor of f. So basically, what we should do is just, well, let me just put them there first. There. We already know that one factor is 1. Wait, hang on. We already know that when one factor is x minus 1. No, sorry. One factor is x plus 2. Right? So it's x plus 2. And then times the other factor, which should be quadratic factor. Yeah? So quadratic factor, let's just put that to x squared. Well, it's x squared because we have an x cubed here. So there is no, like the coefficient of x cubed here is just 1. Yeah? So I don't need any number here. I don't need to put any a in there. So I know that it should be x squared. And then maybe I'm going to put here bx plus c. All I need to do is figure out the b and the c. But the easiest one is probably c first, right? So you can figure out 2 times c here. It must be equal to minus 6 because that's the only way you get minus 6. The only way you get the constant term. So we put that to minus 6. That means c will be minus 3. Now let's figure out b. How do we get b? Well, b will involve with the x squared term, right? So if I do this combination, I get bx squared. And then the other combination here, plus 2x squared. Well, because on the left side, the fx doesn't have any x squared term. So I'm going to put that to 0. Yeah? Well, that's going to make b equals minus 2, right? Because those two terms will have to cancel out. Yeah, so that means the quadratic factor, well, or we can write fx as x plus 2, and the other quadratic factor will be x squared minus 2x and then minus 3. Yeah, so that means if we factorize the quadratic factor here, well, which is factorizable, it's just x minus 3 and x plus 1, right? Which will give you that. So that means the other two factors of f will be x minus 3 and x plus 1. Yeah, let's double check that. Yeah, it's x plus 2 is already one of the factors, so we just say these two are the other two factors. Yeah. Okay, part B. The diagram below, not drawn to scale, shows the graph of gx for x less than or equal 0.5. So 0.5 is around there, right? Yeah. On the same axis, sketch and label the graph of absolute g. So basically just this graph right here, yeah? So we want to plot this graph. Okay, so this is a modulus function. Basically, whatever value you get for the y or the range, it will be made positive. That means for whatever point below the x-axis, these are all negative. So these points will have negative y values, right? Yeah, these points here. So if you put them in the modulus, they will be flipped up to be the positive. So basically, we're just gonna, on the same axis, so we're just gonna do like that. I mean, this part should be the same, yeah? And then that part is just mirror image. We're gonna be quite accurate, so I'm gonna do 2 here. This point will be mirrored up there, and this will be mirrored here. That will be mirrored around here, so I'm just gonna follow that and go like that, yeah? And then this point here should be around here, yeah? So that. Okay, so if it's too hard to just get everything smoothly in the first time, you just, split into points and then plot them separately, yeah? Just see the trend of the curve there. And that will be it for me, right? Yeah, and label the graph G. Okay, I'm just going to do as they say there. Okay, here we go. Next part C. Let f in real number except 0 there. So subtract here means f is going to be all real number except 0. Yeah. R is defined by fx and then 1 plus 1 over x here. Okay. Part I, by providing a proof or counterexample, determine whether f is injective. Okay. Okay. I actually have no idea what that means. Never seen it quite yet in a British spec there. But okay, I'll leave it there here for now. I'll come back to this later. Yeah, this is a unseen walkthrough, so I'm gonna be honest there. Let me skip to number 2. Okay. Those questions I'll be, after the time's up, then I'll come back to that and explain it properly after I have done some research. Okay. Question 2a, part I. Let b, m, and n be positive real numbers, given that log base b of 3 equals m, log base b of 4 equals n. Show that log base b of that equals 3m over 2 minus n. Okay. All right. All right. So we probably have to simplify the left-hand side first, right? So if we simplify the left-hand side, we're going to get log base b. Well, basically 27 is 3 to the 3, right? And 16 is, well, I use 3 here because I see 3 here. And 16, let's make it base 4, right? So this is 4 to the 2. Yeah? And this is all to the power of 1 over 2, right? Yeah? So that's basically just half log base b of 3 to the 3. I'm just going to do big brackets here. Minus log base b of 4 to the 2. Yeah? Now you see I have log base b of 3 and log base b of 4 now. So let's split them there. Well, let's put the number in front like that. Yeah, so we're going to have these terms like that. And as we can see, we can substitute m into this and n into this, right? Yeah. So that's going to be 1/2 3m minus 2, what's that, n, right? So if we simplify that, we're going to get 3/2m minus n as required. That's it. Part II, solve the equation that. All right, so I think, do we have to use the previous answer there? Probably not. Okay. So, okay. Right. Well, there is a property in logarithm where if you have log a base a of b, well, it's going to be equal to 1/log base b of a. So basically you can flip between the base and the argument and do a flip like that, right? I'm using this because I see this. This is base m, but this is kind of almost base m. So if you flip it, you're going to get base m. Now, it's probably easier to keep in this form rather than making m the base. So I'm going to flip this one here. But before I do that, let's change it to this. So I'm going to have log base m. Well, 16 is 2 to the power of 4, right? So I'm going to have 2 to the power of 4. But again, using the log property, you can bring the power here in the argument of the log to the front like that. Yeah? And this is equal 4. And again, using this property here, right? You're going to have to convert the log base m of 2 to be 1/log base 2 of m. Why are we doing this? Well, because if we multiply across by log base 2 of m, we're going to get log base 2 of m here, all squared, plus, well, this will be cancelled, right? The log base 2 of m here will be cancelled, so we get 4 here. And the other side will be 4 times log base 2 of m, like that. Well, some of you might already recognize that this is basically a quadratic in a log function. Yeah, like that. So I mean, it's up to you guys now. You can let maybe t be log base 2 of m, and you're going to transform that equation to this, right? Which is also fine. I mean, I prefer to do it. I mean, you can see that you can solve the quadratic equation now and get the answer for t, and hence get the answer for m, right? But I'm going to do it in a log way, yeah? So I'm going to factorize this, because this is basically a complete square. So that's just minus 2 and then squared like that, right? Yeah, if you expand that quadratically, you're going to get this one, yeah? So that means I have log base 2 of m equals 2. Yeah, just solving that brackets alone. That means if I want to make m the subject, I just undo the log base 2 here. I put the other side to becomes the base of the power there. Yeah, so this is the base, will become this base of the power on the right side, and that will give me 4. So 4 is the answer. All right. Next, part B. Use mathematical induction to prove that 7 to the power of n minus 1 is divisible by 6 for all n as natural number. So the big N here is natural number. All right. So the proof step requires you to do the introductory step first, like the trivial first step. So the first step here, let n be 1, right? Yeah, the first one. So we have 7 to the power of 1 minus 1, which is 6. And 6 is divisible by 6, right? Yeah, so that's not bad. So this is true for n equals 1. Yeah, it's true for n equals 1. Yeah, and then now this is the induction step. When you have, this is the assumption step. So you assume true for n equals k. Yeah, that means 7 to the power of k minus 1 is divisible by 6. right? So what do we have here? We're going to have 7 to the power of k minus 1 is equal to 6 times some integer, where m is a natural number. All right? Yeah? Well, we have this already, yeah? And now the inductive step, this is the assumption step. The inductive step is we're going to try let n equals k plus 1. Just one more than the assumption, okay? So what are we getting here? So we're going to get 7 to the power of k plus 1 minus 1, yeah? So if we derive this, we're going to get 7 times 7 to the k plus 1 minus 1, right? And we got to make use of this because we already assumed to be true there. So we got to make use of that, right? Well, having a look at that, if you make from here, yeah, if you make 7 to the k the subject, you're going to get 7 to the k equals 6m plus 1. Yeah? So I'm going to substitute that into 7 to the k here because look, this is, oh, hang on. I shouldn't have a plus 1 there. Yeah, because I already put it down. So the 7 to the k is basically, right, 6m plus 1, isn't it? Because we already assumed this to be true. Yeah, so we can use it. And then this is 42m plus 7 minus 1. If you simplify that, you get 42m plus 6. And again, because this is about divisibility by 6, so we pull 6 out, we get 7m plus 1. And this is a multiple of 6, right? As 7m plus 1 is an integer or a positive integer there, we can say that 7 to the power of k plus 1 minus 1 is divisible by 6. And now the concluding step, right? So the concluding step, so when you have proven that when n equals k plus 1 is also true, right? Since also true for k plus 1 when true for this is n equals k for n equals k. So basically, whenever you say n equals k, like k can be any number, like 5 or 6 or 7, and then it is also true for the next one. So let's say if k is 5, it's also true for 6. That means if you let k be anything, it's going to be true for the next one. So if you keep doing that for the rest of your day, you're going to see that k can be anything, so it's true for all n, right? So therefore, true for all n when n is greater than or equal 1, right? Because n is just the natural number there. Yeah, so that's it. That's done. Okay? Next, part C. A binary operation asterisk is defined on R by, by that, calculate, this is just to follow that operation there. So it's 8 to the cube root, and y 27 to the power of a third to the power of 3, so that's 2 plus 3 to the power of 3, so 5 to the power of 3 is 125. That's not bad there. Show that operation is commutative. So commutative means that it can, so it's basically A asterisk B is equal to B asterisk A, yeah? So we can prove by, I mean, yeah. So I can just do X asterisk Y there. Distributive commutative. I think commutative is this. If I'm not mistaken, yeah, I could be. It's like if A asterisk B, no, I don't think so. Commutative is A asterisk B equals B asterisk A. Yeah. Is it? I could be wrong, guys. You can Google, but I'm not sure here because I don't normally use this. Commutative, commute. It has to go from one to the other, right? I'm thinking it might be if we. I mean, I have some choices in my mind here. It's either this. Oh, hang on. No, I don't think so. I'm gonna go with this. Yeah, I'm gonna go with this. So yeah, we're just gonna say a asterisk b equals a to the third plus b to the third to the power of 3, and b asterisk a is b to the power of a third plus a to the power of a third to the power of 3, and then we do since. It's probably too easy, I'm not sure. 3 marks, I don't know. Yeah, this is the first time I do this paper, so I've never taught this paper, never seen it before, first time, really. So I'm gonna take my chances here. Since that plus that is the same as that, well, I've got the power 3 there, plus that. Therefore, a asterisk b equals b asterisk a, and asterisk is commutative. Yeah? Maybe I'm gonna annotate the video if I know that this is wrong. So, but that's my. I would say this might be called reflective property rather than commutative. But let's see. Yeah, I'm not sure. I'm gonna Google after I'm done with this paper. I'm at 21 minutes now. Module 2, section B. We're gonna do all section. Question 3. A circle has a center that and pass through the point 3, 7. Determine the equation of the circle. Well, that's easy. So the equation of the circle has the form x minus h squared plus y minus k squared equals r squared, right? So if we put everything in, because the center is 1, 3, so 1 would be the h and 3 would be the k. All right, so this is x minus 1 squared plus y minus 3 squared equals, well, we don't know r squared yet, but we can use the fact that it passes that point and we substitute, right? Substitute x as 3 and y as 7 here. We're going to get r squared here. Yeah? We don't even need to care about the r. We don't need to find it. So r squared is just what? 2 squared, 4. This is what? 4 squared, 16. So that's 20. Yeah? That means the circle equation is just x minus 1 squared plus y minus 3 squared equals 20. That would be the answer there. Next, show that the equation of the tangent to the circle at point A is that. Alright, so at point A, we have 3, 7, so I'm going to draw the circle roughly. 1, 3, so 1 and 3 there, maybe. And the radius is around there. And at point A, we have 3, 7, so I'm guessing maybe around here. And we are finding the equation of this tangent, yeah? This tangent right here. Now, we can find the gradient of the line perpendicular to it first using the circle theorem, that when you draw a line from the center to the tangent, it's going to be perpendicular. And after we have found this gradient, we're going to say it's just 1 over minus the gradient of this line here. Yeah. Okay, anyway, so we know that the center is 1, 3. And this point right here, point A, is 3, 7, right? Yeah. So the gradient of the radius here, I'm going to call it the normal, right? Because it's normal to the tangent. The gradient of the normal is just rise over run, or delta y, which is 7 minus 3, over delta x, which is 3 minus 1. So that's going to be 4 minus 2, or 2. Okay, that's the gradient of the normal, right? Now the gradient of the tangent is then actually, you put a minus sign and flip it. Yeah, if it's a number, then you do 1 over that and put a minus sign in. And then we're going to use y minus y1 equals mx minus x1, yeah? x1 and y1 being 3 and 7. So y minus 7 equals m is just minus 1 over 2. We just found it here. And x minus x1 is 3, okay? I'm going to multiply across by minus 2, yeah? So I'm going to get minus 2y plus 17 equals it's going to cancel with the 1 minus 1 over 2 there, so I get x minus 3 here. And that's the point. So if I move everything to the right, but I write on the left, I get x plus 2y, yeah, and minus 17, yeah, that's as required. Okay, that's done. Part B, determine the points of intersection of the parabola and the line. So this is solving simultaneously, right? Well, probably the easiest way is to make y the subject here, because I can see that there is only y term there that I need to eliminate to make it all quadratic. So as y a subject, we have minus 2x minus 3 for the linear equation there. And then we're going to sub this to this, yeah? So I'm going to have x squared minus 3x minus 5 minus 2x minus 3 equals 0. Yeah, don't forget the sign there. A bit tricky sometimes. So if we simplify this, we get x squared minus 3x minus 5 plus 2x plus 3 equals 0. Yeah? Simplifying it again, we get x squared minus x minus 2 equals 0. So if we factorize that, we get x minus 2 and x plus 1 equals 0. Yeah? So x equals 2 and minus 1 for that. If we plug that to the linear equation correspondingly, we're going to get y equals. The first one, plugging x equals 2 in, we get 2 in here. So that's 4 plus 3, 7. So y is going to be minus 7. And then if we plug minus 1 in as well, we get minus 2 there. Minus 2 plus 3, we get 1. Yeah, on the left side. So y will be minus 1. All right. So there you go. Let me double check, yeah? Because I'm going to be thorough there. Yep, I think I'm okay with that. Yeah, so to mean the points of intersection, well, I think we should write it in the coordinates form. So the one point is 2 minus 7, and the other point is minus 1 minus 1, right? Yep, okay, that's the answer there. Next. Part C, two vectors are given as OA and OB. Calculate the magnitude of vector AB. Right, so the magnitude of vector AB, well, vector AB is just OB minus OA. Yeah, it's AB is a relative vector, so you do OB minus OA. If it was AC, then you would have done OC minus OA instead, all right? So OB 205 minus OA minus 113. That's going to give me 2 minus minus 1 is 3, 0 minus 1 is minus 1, 5 minus 3 is 2, right? Yeah. Yeah, I'm double checking. Yeah, I'm happy with that. And then we're going to find the magnitude of this vector. That's going to give me a Pythagoras of 3 squared plus minus 1 squared plus 2 squared. Yeah. So in the square root, we have 9 plus 1 plus 4. So that's going to be a square root of 14, right? And now here's time to find, well, because I noticed that in the cover of the exam, unless stated otherwise, you're going to give it to 3 significant figures. Unless the question states that you need to do exact, you need to give it 3 significant figures. So I'm going to use a calculator here. And this is square root 14. Yeah, so that's going to be 3 significant figures, 3.74. Yep, that's it. Okay. Determine the angle between the vectors. All right, so we're going to use dot product then. The vectors in this case would be assumingly these two. So cos theta is going to be OA dot OB divided by modulus OA times modulus OB, right? So OA dot OB, so minus 1 is just multiplying separately all the components to the same component on the other vector and add them up, right? So basically minus 1 times 2 is minus 2 plus 0 plus 15 divided by the magnitude. So I'm just going to do Pythagoras there. minus 1 squared is just 1, 1 squared is 1, 3 squared is 9, times square root for the other one. 2 squared is 4, 0 squared is 0, 5 squared is 25, yeah? So I get here cos theta, or I can do arc cos already. So theta is arc cos. So the top one is 13, the bottom one would be square root 11 times square root 29. Let's use a calculator there. And 3 significant figures, of course. Cos, arc cos instead. The angle in, I'm just going to assume degree, right? So 13 divided by root 11 times root 29. All right. You know, I'm going to go check the cover of the paper again, see if I need to give specific unit, yeah? Let me just go back on the cover page. Yeah, I noticed that unless stated otherwise, you're going to give it the 3 significant figures. The answer that is not exact must be written, yeah. Wait. Unless otherwise stated in the question, any numerical answer that is not exact. Oh, so we got it to be exact just now for that root 14. And then, yeah, okay. That's fine. We're okay. So for this one, I'm going to give root 14 because it is exact, right? It is exact. But this one, not quite exact. So I'm going to give it 43.3 degrees. Yeah. Okay. Question 4a. Show that that is equivalent to tan alpha. Well, yeah. Well, you can do double angle here. You need to know double angle, right? Okay, so let's do double angle. Cos 2 alpha there is going to be 1 minus 2 sine squared alpha. This is using the double angle formula. And also sine 2 alpha is going to be 2 sine alpha cos alpha, right? Yeah? So if we put everything in there, we're going to get, what do you know, you got to put in brackets there, 1 minus 2 sine squared alpha, all divided by, yeah. Sine 2 alpha would be 2 sine alpha cos alpha. Let's see how that goes. So that's going to be equal to, well, 1 cancel with 1, we get a negative sign expanding in, we get a plus 2 sine squared alpha divided by 2 sine alpha cos alpha. The sine alpha cancels, yeah? And the 2 cancel, so the top there we only get sine alpha, the bottom we get cos alpha, so that's going to be tan alpha. Yeah, which is equal to the right hand side as required. Yeah, that's done. Part B, solve the equation. Okay, so by the looks, I can factorize that out first. So I get 10x, and then I have 10x minus 1 equals 0. Yeah. Well, because this is 2 brackets multiplying to 0, so one of them, yeah, either this one equals 0 or this one equals 0, right? So for this one equals 0, so if we do arctan, yeah, what angle gives tan a 0? Is 0 or pi? It's just the same as sine. So sine 0 and sine pi will be 0, yeah? So this will be x equals 0 or pi, right? That's fine. Well, we can also do minus pi. Hang on. We can't take pi because they don't accept pi there. The range doesn't cover pi. So we can't take pi. We can only take 0 there. All right. Nor can we take minus pi there. For this one, well, we have tan x equals 1. Well, what angle gives tan equals 1 is tan pi over 4, yeah? So x will be pi over 4. But this is a positive quadrant, so it's pi over 4 here. It can also be here as well. So that's pi plus pi over 4, but that's out of the range, right? I can't do negative either, so that's probably the only answer there. Yeah, let me just double check that. If we go the 4th quadrant, no, we're not going to get it. Hang on. We can do this one. So this is the cast diagram method, right? For the tan giving a positive value, you should know that it is this line here. And this is called the principal solution. It's just the acute angle when you do arctan 1. You do that in a calculator, you should get pi over 4. But you should try subtend the angle from the initial line here to get the other angle. So we still have this line, yeah. But that red subtending is going to give you over pi, which is out of the range, right? That arc angle, that arc measure there is more than pi. So rather than doing like that, we can do negative here, yeah. So this angle is a negative convention. But what is the actual size of the angle? Well, it's just pi and minus this, and you put a negative sign. So this angle is basically pi minus pi over 4, right? And then you put a negative sign into it. So that will be equal to pi minus pi over 4 is 3 pi over 4, right? So that's negative 3 pi over 4. That's the other one there. Yeah? Now we got 2 for that. Okay. So the answer is then 0 pi over 4 minus 3 pi over 4 for the x. All right? That's it. Part C. Let g theta be that. Show that g theta is that. All right. So this is called harmonic form. You have to, yeah, okay. So we're going to put this to cos, let's put it to r cos theta plus alpha first, yeah, because I'm just looking at this form here. And then if you use the additional formula, you should know, I think, that is just r cos theta. Wait, hang on. The additional formula of cos A plus B is going to be cos A cos B minus sine A sine B. All right. So for this only, yeah, and also the r. Okay, I'm just going to put r outside here. So this is cos theta cos alpha minus sine theta, well, theta, yeah, sine alpha, yeah. And if we put everything in, we get cos theta. Well, I'm just going to rearrange like this. So I'm going to have cos alpha first. I'm just switching the two, yeah, which is possible to do. And minus r sine alpha sine theta, like that. Now, we got to match here, right? Because at the end of the day, we want to put it to this form, right? Well, this form, we put it to equivalent to this form, yeah? That means if we look at each term, the cos theta here is going to be the same as that. That means that this root 3 is going to be the same as that. So we can write r cos alpha equals root 3. And the other one is, you know, the same concept. Sine alpha is this. Then what is r sine alpha equals to? I mean, sine theta is already the same here, yeah? So that means r sine alpha is just, it seems to be nothing, but it's actually 1. It's just in front of sine theta there, 1. Now, if you do, if you square both terms, r squared cos squared alpha equals 3. If you square this, you get r squared sine squared alpha equals 1. If you add them up, right, I can factorize r squared out, and I get sine squared alpha plus cos squared alpha equals, I'm adding them up, yeah, equals 3. So this is the identity of trigonometry. That goes to 1. So that means r is root 4, which is 2, right? Well, we get r of 2 already. We can put r to maybe the cos there. So 2 cos alpha is root 3. Yeah, I'm using this one. So that means alpha is arc cos, right? Root 3 over 2. And arc cos root 3 over 2 happens to be 30 degrees, which is pi over 6, right? So I think we proved it. R is 2 and alpha is pi over 6, right? So therefore, g theta is just 2 cos theta plus pi over 6 as required. Yeah, that's it. I, hence or otherwise determine the general solution of G. All right, so general solution of G. Interesting. General solution. Does that mean the roots? I'm gonna assume it's the roots, right? General solution. What is that? I mean, this is not an ordinary differential equation either. Okay, that's a bit weird. General solution of G. I'm gonna assume, right? I'm not sure about this. Yeah, I'm gonna assume that it means we put G theta to 0. I think it should be. Yeah, general solution for G. Let's go back to. Yeah, I'm gonna assume that, right? So that means 2 cos theta plus pi over 6 equals 0. Is that right? That feels weird, but I'm not sure. I mean, we don't have the domain either here, the theta. So, okay, hang on. General solution. Yeah, all right. So, okay. I'm gonna go with this. So what cos gives you 0? It's pi over 2, cos pi over 2, or minus pi over 2, right? So theta plus pi over 6 here will be plus or minus n pi over 2. Is that right? So and n is 1, 3, 5. So let's do better there. So let's do, because n has to be an odd number. So let's do 2n minus 1 pi over 2 like that, where n can be, anything from 0. Let's start from 1. So if start from 1, we're going to write natural number like that. So this is saying that it's a multiple of an odd multiple of pi over 2. So like pi over 2, 3 pi over 2, 5 pi over 2. And they can be minus. So it's just, you can try plug that in a calculator. So to give cos of 0, you need 90 degrees or 270 degrees and so on. It could be minus 90 degrees, it could be minus 270 degrees, could be plus or minus. And this is probably the general solution they refer to. But we're not done. We need to move this to the other side. So we need to simplify that. Just going to put here. So theta is, how do we simplify that? Hang on. Yeah, probably we're gonna have to keep it in that form. So it's minus pi over 6 plus or minus. You know what? I'm just gonna change this to an integer instead. Yeah. And then we can do a plus, right? 2n minus 1 pi over 2. And if we simplify that, right? I mean, n can be anything now. It can be 0, it can be 1, it can be 2, but it just have to be integer. If we simplify that, yeah, what do we get? Well, minus pi over 6 plus n pi here, yeah? This is, if you multiply that, you get n pi. And then minus pi over 2. So that's going to be what? Minus pi over 6 minus pi over 2. So you get minus 2 pi over 3, right? Is that right? 30 plus 90, 120. Yep, 120 is that. Okay. Plus n pi. That's n pi there. Yeah, so I'm going to simplify it to n minus 2 over 3 pi like that. Yeah, that's the general solution then. So it's just any n value and you get the angle to be the answer there. Okay, that's my best shot. I think I'm not sure what they mean by general solution here, but I'm just going to put it to 0 and solve just like that. And because they don't give the domain, we're going to assume that n can be anything, so it can extend to 90, to 70, and you keep adding by 90 or keep subtracting by 90. It's going to be fine. either way. Part D, determine the Cartesian equation of the line L. Whose parametric equations are given as that? All right. Well, that's not bad. We're going to make t the subject from this one, maybe. So t is, that's going to be x plus 5 divided by minus 6. Yeah, or we can put it as minus x plus 5 over 6, like that. We're going to put that to y equals minus 2 minus 8 times minus x plus 5 divided by 6, like that. Yeah? So this is going to be, hang on. Sorry. This is going to be minus 2 plus, yeah? So the minus and minus here will cancel. We can ignore that. So it's just 8x plus 40 divided by 6. Yeah? And then we can simplify that. So if we multiply by 6 over 6 on this one, we're going to get minus 12. And then we can merge the fraction there. And all divide by 6, right? Let me move everything to the left. And then we're going to have, well, if you simplify the 40 and minus 12, you get 28. Yeah? So we're going to get 8x over 6 plus 28 over 6. 8x over 6, we'll simplify that to 4 over 3x. And then that was simplified to 14 over 3. Yeah, so that's it. That's the Cartesian equation, I think. Let me double check, yeah? So x plus 5 over minus 6. Yeah, I think I'm happy with all that. All right, yep. A plane P passes through that, and has a normal vector that. Determine the vector equation of the plane. Interesting. This is, in the UK syllabus, this would have been in further math, but they put it in pure math here. Very, very, that's some bold move there, I must give. Okay. Okay, let me think. I might need some time. Right. Okay. Because it doesn't say Cartesian equation or what kind of equation, I'm going to give it both. So basically the vector equation of a plane can be like this. So it's just some r, which is the position vector. Normally r is just x, y, and z, like that, yeah? So r dot normal vector is just any point on the vector. Yeah, actually it should be, yeah, any point on the vector dot also vector n. So any point on the vector means this is a position vector, yeah? We can do that. So this is r dot 2, 8, minus 7 equals a. I'm just going to take minus 3, 2, 1 here. Yeah, normal vector dot normal vector 2, 8, minus 7. Basically that. So if we dot the right part, we're going to have minus 6 plus 16 minus 7. And that's going to be minus 13 plus 16 is going to be 3, right? So, I mean, if we want the vector form, that is just done. It's just r dot that equals 3. Yeah? So it's r dot that vector equals 3. Or we can put Cartesian, right? So the Cartesian form would be, because r is basically x, y, and z dot 2, 8, minus 7 equals 3. So you would have what? X 2x plus 8y minus 7z equals 3. So I think we should answer this form. Yeah? That's the vector equation of the plane. Okay. I mean, you could have used any point here rather than this. You could have used that. You could have used that as well. All right? Okay. I think I'm okay with that. Module 3 now. I think, yeah, we're still fine. 5. Evaluate that. Okay. Well, limit x approaching 0. Because if you substitute x to this, both of the denominator and numerator become 0, so we need to do L'Hopital, yeah, L'Hopital's rule. So if we're going to prove first that lim sine of 3, 0 divided by 2 of 0 is 0 over 0, so we use L'Hopital. That means lim of x going to 0 of that over that. Well, we differentiate the numerator and denominator, right? This is undefined, yeah, we just write that. We apply the L'Hopital rule, so we differentiate denominator, we get cos 3x times 3 outside because that's the chain rule, divided by differentiating 2x, we get 2. Now if you try plug in 0, if you don't get 0 over 0 now, then that will be the limit, yeah? So this will be now 3 times 1 over 2 because cos 0 here is 1. So the limit will be 3 over 2. Okay, that's it. Using first principle, differentiate that with respect to x. Now the formula for first principle is d by dx of fx is going to be equal to limit of h going to 0 of, yeah, over h here, fx minus plus h minus fx. That's basically finding the gradient of 2 points that are very, very close together on the line, yeah? Now, because we're going to put fx as that, right? Yeah. Let's see if we can complete square, maybe. Maybe not. Yeah. Let's see if I can put this to a complete square. Maybe I shouldn't. Yeah. I'm going to do fx plus h here. So that's just all that. Yeah. And let me simplify this first before I put it back to the formula here of first principle. So that's 5 times x squared plus 2hx plus h squared plus 4x plus 4h minus 2. So expand again, we get 5x squared plus 10hx plus 5h squared plus 4x plus 4h minus 2. So simplifying all that again, we get, oh, that's it. That's already simplified. We can't really simplify anything there because all the terms are unique. Okay, so d by dx of fx then is going to be, again, lim x going to h going to 0. So we're going to put this whole thing because it's the fx plus h, yeah? And then we're going to put them onto the fraction like that, which is a bit much here, but we need to do. Minus fx, which is this guy, so we're going to be careful with all the signs, right? Yeah. And then this will be minus, so you put minus into this whole thing, it's going to be minus x, 5x squared, minus 4x, but plus 2, because minus 2 is plus 2, all divided by h. Now before we put h to 0, we should try simplify this first, right? So simplifying this, like 5x squared cancel, 4x cancel, 2 cancels. We only have what? Yeah, if you look, it's 10hx, 5h squared, and 4h. We can factorize h out. We get what? I'm just going to put 5h here first, and then 10x, right? And then 4, yeah, like that, divided by h. And now do you see that the h can also cancel? So this will just be, now you can substitute h to 0 now. So you're going to get just 10x plus 4. And if you try differentiate this using a normal method to check your answer here, it should be the same. So 5x squared differentiate to 10x, 4x differentiate to 4. So that should be correct, yeah? Without any doubt. Next. Given that, part C, given that y equals x cubed, sign that determine dy by dx. So seems like we need to use product rule there. So dy by dx is just, So I'm gonna do u dv first. So u is just the first one. dv, we're gonna differentiate sine to the 4 here. Okay. So looking at the outermost function, we're gonna have, you can, go to my video here where I, go through the simple concept of chain rule. Yeah, just check out the video there and don't forget to come back. So we bring the power down. This is a power rule. Yeah, 4 sine to the 3, and the argument doesn't change here. But because the argument is not x, it's something else, it's a complicated expression, we're going to differentiate the inner part there. So differentiate this inner part, we get 6x, and that's it. And we multiply to this, right? So that's why I get 6x here, multiplying that. That's the u dv, and plus v du. So so differentiating that, yeah, is 3x squared, and we keep sine to the 4 the same, right? Unchanged. And that's it. So if we simplify all that, we should have, if I take x squared out and sine to the power of 3x squared to the power of 3x squared minus 2, and then here I have brackets, that would be 4x, yeah. Ooh, hang on, I also have another x here, right? So that should be x squared, and this is 24. Is that right? Yeah, that should be 24. Let me check that. Yep, it is. And then plus, taking x squared out, we just have 3 here. 3, and then that is just sine, because there's going to be sine left here. And that's it, I think. So that's just it, dy by dx. All right. Next. Ooh, what do we have here? Interesting. This is similar to the A-level question. Okay. Part D. Water is flowing into the empty right circular cone at a constant rate of that per minute. So this is volume dV by dt. The depth of the liquid in the cone at time t in minutes is x centimeters. Okay, we can see in the diagram there. The angle alpha between the perpendicular height of the cone and the slant height is arctan of that. Okay, so we know this angle, right? Arctan of that. So this is basically, it's basically 1 over root 3. So that's pi over 6. Yeah, so this is pi over 6. The volume of the cone can be calculated by this. All right, that's what we know. Show that the volume V of water in the cone when the depth is x centimeters can be expressed as that. Okay. All right. So basically, because we have the radius here as well, we need to find this radius. Yeah. And, r over x here will be tan alpha, right? So r over x is equal to tan alpha, which is, it's just this guy, basically. Because they give you that alpha, right? Look, they give you that the angle alpha between that is arctan. You don't need to use a calculator here. I mean, when you undo the arctan there, you get tan alpha being root 3 over 3, right? So that's why I'm going to write root 3 over 3 here. That means the r, because they don't have the r here, we need to prove that in terms of x, right? So r equals tan alpha is that and times x, yeah? So that means when we put back to the volume equation, we're going to get 1 over, what's that? 1 over x? 1 over x pi r squared h. That shouldn't be right. This should be a 3, yeah? Okay, that's a typo. That should be a 3. 1 over 3 pi r is root 3 over 3 r squared. H is also x, right? Let's see. If we get to this formula, then we are fine, right? So that's going to be 1/3 pi. That's basically 1 over 3 there. X squared times x. Yeah, we get what they want. So that was a typo. Yeah. As required. Okay. Calculate the rate at which the height of the water is increasing when the height of the water is 6. Right, so we're going to calculate the rate of the height, rate at which the height is changing. So that's dh by dt. Well, we got to go to the chain rule equation first. Now, in this question, the important parameters are h, v, and t, right? Hang on. H, yeah, H. No, this is not H, it's dx by dt, because x is height of the water. Gotta be careful there. H is the actual height of the cone, right? Like the actual height of the cone, like the cone, not the water. Okay, so dx by dt is dx by dv times dv by dt. Yeah, so this equation will link x, v, and t together. Yeah, dv by dt we are given. Yeah, we are given at first was 8. It was 8 there. So we put here 8. Now what is dx by dv? Well, we just have to find dv by dx first. And that's the point why we found this relationship here. So dv by dx there was just, if you differentiate x cubed there, you're going to get 3, 1 over 9 pi, and this is going to go to x squared. So that is just basically 1 over 3 pi x squared, right? So here is 1 over 3 pi x squared. I'm just going to put, so that means dx by dv, because we want dx by dv here, it's going to be 3 over pi x squared instead. Just flipping everything upside down and downside up, like that. Now the problem here is that we need to know x, and now it gives you already when the height of the water in the cone is 6. So that is saying x equals 6, right? So we're just going to substitute 3 over pi times 6 squared times 8 here. Yeah, we're home free. So that's going to be 24 over 36 pi. That's going to simplify to, well, this can be kept as an exact form, right? So 12 is 2 over 3 pi, like that. Yeah, so I'm just going to go with that. dx by dt. Okay, so that's it. Yeah. Okay, number 6. A. The mass of population of a certain microbe triples every 4 hours, and after 6 hours, the mass of population is that. Calculate the mass of population of microbes at time t equals 0. Ooh, okay, note that. Interesting. Okay. Okay. Triple every 4 hours. And after 6 hours, the mass of population. So it triples every 4 hours here. That means, let's say the population is P, and then it's going to be equal to P0. That's the initial population at t equals 0. Yeah, at time t equals 0. This is P0 here. This is the thing we want. And then because this is triple every 4 hours, so the factor is 3 here. Every 4 hours, right? So, okay, so that's going to be t over 4, where t is number of hours, right? Like that. Yeah? So if it's t equals 4, then the factor will be 3. And after 6 hours, the mass population is that. Okay, so we're going to put 375 equals p naught times 3 to the 6 over 4, like that. And I guess that's it. Yeah, did I make it too easy there? Right? So p naught equals, just use a calculator there, 375 divided by 3 to the power of, that's 3 over 2, right? Yep. Interesting. We don't get an exact form. Yep, we're going to go with that. So 72.2, 3 significant figures. All right. Probably have to go with that, yeah. Grams. Yeah. Does this work? Let me try. So triple. Yeah. If we put t equals 8, that's gonna triple twice, right? If t equals 8, so or 8 hours, it's gonna triple 2 times, so it's gonna times 3, and it's gonna times 3 again, so that's 3 to the 2. So that makes sense. Yeah, it should be that. Yeah, I think I'm gonna go with that. I mean, this is 10 marks. Right, it should be that easy, should it? I don't know, man. Okay. This should be some kind of integration question. Let's see. The mass of population of a certain microbe triples every 4 hours. And after 6 hours, the mass of population is that. Because this is an exponential function. So it's like dp by dt, yeah? Maybe we are meant to solve the differential equation there. It's going to be directly proportional to itself, to the population, like that. Right? I'm thinking. Yeah, I'm gonna try this, yeah? Yeah, probably that. I think probably that. This is the basic differential equation for exponential growth. So if we move 1 over p there, dp equals k dt. And then we're going to integrate that. Yeah, that's why they give you this. So you're going to have ln p there equals kt plus c. Yeah, let's see if I get the same answer here. Yeah. Okay, triple every 4 hours. Should we know that? Should we know something about that? Triple every 4 hours. Okay. Yeah. So if t equals 4, then right. So this is going to be ln 4 times triple would be 3 times p naught equals, well, okay, let's do t0 first. So if t equals 0, we're going to make p equals p0, right? So that's going to be ln p0 c, like that. So that's the c value. So we're going to put that as ln absolute p minus ln absolute p naught. I mean, as the population is positive anyway, we're not going to put absolute. So this is just ln p minus ln p0 equals kt, right? Or that is ln p over p naught equals kt, yeah? Seems like I'm out of space there. Okay. And then, okay, so, all right. And then we're going to use that fact there where every 4 hours is going to triple. So if t equals 4, then p equals 3p naught. So we have ln of 3, right? Ln of 3. Because 3p naught divided by p naught is 3. That's going to give me 4k. Yeah? So we have k here is ln 3 over 4, right? That's the value of k. So what do we have? If we put everything together, ln 3 over ln 3 and all divided by 4t, like that. Okay? Well, we can simplify the equation here. This is, again, p over p naught. I forgot to write that. So let me write that again. Ln p over p naught, yeah? Okay, now the last condition where after 6 hours the mass is 375. All right, so T equals 6, P equals 375, right? We're going to find P naught there. So ln 375 divided by P naught equals ln 3 all divided by 4 times, what's that again? 6. Yeah? And then we're going to solve that equation. So how do we do that? Yeah, let's just do this equals, that's just e to the power of all that. Yeah? So that means P naught would be equal to, I mean, if I swap this, I get 375 over P naught, and the other side will be 1 over, right? 1 over this. I'm just going to do 3 over 2 ln 3 like that. And we move 375 to the other side. See if I get the same answer there, yeah? No idea. Whoops. I don't like that. Hang on. Delete. Okay, this is weird now. Uh-oh. All right, never mind. I'm going to write down here. Let's use a calculator. E to the 3 over 2, no, 3 over 2 times ln 3. There you go. That's exactly the same answer. I guess they want you to maybe, because it's 10 marks, right? So I'm suspecting that this should be your thing, your go-to working. But I'm just going to kindly suggest that this is the alternative, right? Which is also possible. Because if the question says use integration or use differential equation or solve by first stating the differential equation, then yeah, this is the only way, but because it doesn't say, so that will be my alternative there. But you should stick to this because the marks is quite a lot there. It's 10 marks. Yeah. Anyway, part B. Okay, we're at 1 hour and 12. The diagram below, not drawn to scale, shows the graph of the curve that and the line that. Okay. Calculate the volume of solid of revolution generated by revolving the region bounded by the curve and the line. Okay. So bounded by the curve and the line y. Okay, so basically we're going to revolve this area. Okay. So basically you just let's see what we can do. Okay. Yeah, hang on, let me think. Okay. Well, basically, if it's the curve alone, then it's pi y squared dx, right? That's the volume of solid revolution. But if we have to subtract the inner part here, let's see. So let me imagine that. So it's basically going to be just the ring area. If we take a single strip there, it's going to be the ring area there. So it's basically going to be, yeah. Okay. So this will be pi y2 squared minus y1 squared. And y2 being the outer one, which is the curve, and y1 being the y equals 2 here. All right? So that's going to be the volume. And this will be from, I think we should do either half, right? And then multiply by 2. So I'm going to do 2 pi integral from 0 to, okay, let's find the x-intercept first for the curve. No, we should find the x-intercept for the line and the curve first. So we put them to equal, x8 minus x squared equals 2. And then we have what? X squared equals 6. So x equals plus or minus root 6, right? Yeah, like that. So that means if I'm just going to do this half and multiply by 2. Yeah, it's the same thing. So we're going to go from 0 to root 6. Yeah, because when you have 0 around, it's nice. It's simpler. Yeah. Y2 squared is just this guy squared, right? So we're going to have this thing squared and then minus. Yeah. Y1 squared is just 2 squared, so it's 4 here, and then dx, right? Or this dx. All right. And then this is 2y integral, the same bounds there, 0 to root 6. And then we're going to expand that, right, first. So it's x to the 4 minus 2 times 8 times x to the 2. So that's 16x to the 2. And plus 64, because I also have a minus 4 here. So I'm just going to wrap that to 60. Like that. Okay? Right. Wait, hang on. I start to think if I do subtraction like this, then it should be these points instead. Okay, that's not going to be the same now because the x changes there. This is wrong. That's the curve. Right. Let me think. Very interesting. Okay, because I'm gonna play safe here, I'm not sure if this formula works, but I don't think so now because you're gonna have to subtract the whole revolved volume here. So that's gonna look like a UFO when you revolve the whole parabola. And then you're gonna subtract by this thing, revolving the red bit there. So I think this doesn't work. Nope, sorry. What would work, I think, is to split. Yeah, so we're gonna probably split. Like, I can do the whole thing. Yeah, I can do the whole curve. So I'm gonna get a UFO as I mentioned. So it's gonna look like that. Yeah, this is gonna be the, the volume of the solid there by the curve alone. But then if you do the, just the line there up to this part, and when you revolve it, you're gonna get a cylinder. Yeah, but do you see that you are missing this volume here? Right, on either end. So that's like a dome. That's like a dome. So how do we get that dome and also subtract from the whole thing? Well, basically, yeah. Basically, we can, I think we can just try find this revolving first. Yeah. Okay, so we're gonna find that bit. And then this will be what? A cylinder. So you have a cylinder here with this. Yeah. Bounded by the curve and yeah. So because we only need the UFO where you take out these parts, right? You only want that. Yeah. Okay. Yeah. So okay. So we're gonna do the UFO first. So the volume of the UFO is integral y squared dx. We times pi here, and this is gonna go from, if you find the y-intercept there. So this is 8x squared, 8 minus x squared equals 0. Yeah, so we're gonna have x equals plus or minus root 2. 2 root 2, sorry. And again, I told you earlier that we're gonna do half. Yeah, so we're gonna do 2 times 0, and then this is 2 root 2. Just half and then multiply 2, because it's nicer to have 0, as I mentioned. So this is going to be the volume of the full UFO without any subtraction. Yeah. But note that we only want this part and revolve to be this part. It's like the UFO got cut in the middle, if you know what I mean. So that's going to be 2 pi, and then we're going to integrate this, right? So what is that? Basically, that is 64 minus 16x squared again, plus x to the 4. Yeah. And we integrate that, we get 64x minus, so integrating x to the 2, we get x to the 3, so that's 16 over 3, x to the 3 plus x to the 5 over 5, right? And the bounds would be from 0 to 2 root 2. Okay, let's calculate that. Let's put it to exact value first. As you can see, 0 goes away. Yeah, all the terms substituted 0, they're going to go away. So I'm just going to do subbing in that to each term there. Yeah. So that's going to be 128 root 3 minus root 8 to the power of 3. Well, you can do, that's complicated. Okay. You know what? I'm just going to do 16 over 3. Because this is again 8 to the power of 1/2, right? It's root 8 there, so it's 3 over 2. Yeah? Using laws of indices there. And this is again 8 to the power of 5 over 2 over 5. Yeah. Okay, so that's the volume of the whole thing. Now the volume of the cylinder, this is volume of whole thing. Volume of cylinder, yeah? It's just going to be equal to, cylinder is just it's just pi r squared h, and pi is pi is pi, r is this guy, just the height of that, so that's 3, right? Because this is y equals 3 here, so that should be 3. So it's just pi times 3 squared, and then times the height. Well, the height is just this. Now we got to be careful here, because we have mentioned that this is just going to be this for the cylinder, and it's just that length that we need. Okay, and we already found it here because they cut at plus or minus root 6, so the length of this to this will be 2 root 6 then. Yeah, so 2 root 6, okay, for that. So that's going to be what? 18 root 6 pi, right? That's the volume of the cylinder. And now what? The bits here, this bit. Okay, that bit there is like a dome. Yeah, I call it the dome then, V dome. It's going to be equal to, well, this is from what? This is from root 6 to root 8, right? Yeah, and we're going to do the volume of revolution from that. It's going to be still this curve, so that's easy. We can already use this, right? So that's going to be 2 pi. No, not 2 pi, just pi. But then all that, yeah, with the bounds of root 6 to root 8, right? Because we revolve from root 6 to root 8. And that's going to be, something similar to what I got earlier, probably. So this is 64. Yeah, that's, hang on, that's weird. Why is this root 3? That shouldn't be root 3, that should be root 2. Yep, okay. All right. So that's 64 root 2. No, it's the same. Yep. 128 root 2. Yeah, as you can see, this is the same, right? Hang on. This is the same. So it's the same here and the same here, right? Okay. So that's can be, okay, copy that. I'm checking now. Yep, should be fine. And now, because we have 2 domes, right? So we gotta multiply all that by 2. now we do all the subtraction, which is this v whole subtract v whole minus this and this. It seems like how is that impossible? Oh, I haven't subbed in the lower bound, sorry. I haven't subbed in this. Yeah, okay. So we're gonna get that. That's just the upper one. So we're gonna minus 2 pi down here, yeah? So this and then minus this, right? 2 pi, subbing in root 6 basically. So 64 root 6 minus 16 over 3 root 6 to the power of 3. So that's basically root 6 to the power of 3 over 2 plus 6 to the power of 5 over 2 divided by 5 basically. And then v of the required solid, yeah, would be, well, it's just v whole minus v cylinder minus 2v dome. Now, as you can see, if you do that minus that is okay, but that minus that is going to cancel, right? Because we have the same upper bound here and same integral for the curve. So it's going to be just left with minus, because we are subtracting by that, right? So it's minus 18 root 6. And because we minus, and this is a minus, right? Yeah. So it's going to be a plus of this thing. Yeah. So plus that. There, which is this term. So I'm not going to write there, but I'm going to use a calculator, guys. Yeah. Minus 18 root 6 plus 2 pi brackets 64 root 6 minus 16 over 3 times 6 to the power of 3 over 2. Yeah, is that it? And plus 6 to the power of, what's that? 5 over 2. And then divided by 5. There you go. At least the answer makes sense. It's not a negative or anything. All right. Wait, let me try minus. Oh, I forgot a pi here. That should be a pi here as well. Yeah, this is 9 times 2, 18 root 6 and pi. So I need to add a pi for that as well. That should be a pi. Hang on. Let's put a pi here. Pi. Okay, that makes more sense. Maybe. So that is equal to 464. That's it. Oh, 465, 3 significant figures. Okay, I'm just going to keep my answer as that. That should make sense. Like if we maybe only find the volume of the cylinder, see if it's too much. 18 root 6 and then times pi. That's the cylinder alone is like already 100. Right? So that's not much at all. Okay? That is possible. Now let's do this question. I'm at 1 hour and 28 minutes now. The diagram below, not drawn to scale, shows the curve and the line y equals x minus 2. Calculate the area of the region enclosed by the curve and the line. Okay. So basically it's just these two and we are finding this area. Well, that's easy because this is where the line is above the curve. So this is the line, this is the curve. So we can do integral y line because line is above, so we do that and subtract y curve there and dx. That's it. Now we need to find the intersection here first, and let me call this x1. Well, that seems to be 0, but we're going to prove that. This is x2, and we're going to use the bounds to be x1 and x2 like that. So that should give you the area. All right. So let's find the intersection first, see if they cut at 0 and somewhere, or 1 there maybe. So x minus x squared minus 2 equals x minus 2. Okay, so x squared minus x equals 0, so x and x minus 1 equals 0, so x equals 0 and 1. Yeah, exactly. So that is 0 and 1 there. And then we're going to put y line first, so the line is x minus 2, because the line is above the curve there at the area. And then subtract, yeah, the y of the curve, or the function of the curve, basically. So it's actually integral. So x minus 2 minus minus 2, so that goes away, and then we have minus x squared instead here. Yeah, that's fine. And I put this to dx, and the bounds is still 0 to 1. So integrating that, we get x squared over 2 minus x cubed over 3. The bounds is 0 to 1. Okay, and after that, you just sub in the bounds, you get the area. That's it, home free. 0 subbing in, everything disappears, so I'm just going to sub 1, so that's 1 over 2 minus 1 over 3, so that gives me 1 over 6. Nice. Yeah, so that's it. Oh, that's the end of the paper. Alright, so that's the end of this paper, and now I think I will need to check about the questions that I skipped or not sure about, and I'll be back. Okay, I'm back. So I've marked the paper I did. There is this one here that I need to amend, because this question I had no idea how to do, honestly. And now I know. Well, let's do it then. So basically we want to prove this function, whether it's injective and surjective, right? So to prove injective, it's quite simple. Basically, you just prove whether this function is a one-to-one, okay? Now, because we need to provide solid proof and not by graphing or not by exhausting any numbers, how do we prove this to be one-to-one? Well, basically, if you set this function, so a function is basically, you can think of function as having inputs and outputs, right? So if I have x1 as an input, it's going to give me fx1 as an output, just basically subbing in x1. If I have x2 as an input, I'm going to have fx2 as an output, right? Now, so to prove one-to-one, it means that for any single input, it must always give only one output, or vice versa. So one output must be given only by one input, right? So let's say that we assume that x1 and x2 are different, yeah, and these are their inputs. And if somehow we can prove that for any two outputs to be the same, it's impossible, and that's going to be one-to-one. So if you assume first that, okay, I'm going to assume that the function can give the same output by different inputs, yeah. That is just to assume that fx1 equals fx2. If somehow we can find more than one answer to x, then that's not going to be one-to-one, right? So let's see. So if x1 doesn't have to be x2, in this case, it's not going to be one-to-one. But if we plug in the function there, so on the left side, we're going to have 1 plus 1 over x1 equals 1 plus 1 over x2, right? So 1 cancel here. What I have there is 1 over x1 equals 1 over x2. Now, because we know that the domain, yeah, the domain here, that's the domain. The domain cannot take 0 anyway. So we can simplify that to x1 equals x2. And that is saying that if you want to make two outputs to be the same, you gotta have the same input, right? You gotta have the same input. That is saying that to make fx1 and fx2 equal each other, the only case where they're possible is for the input to be the same, right? So if you take any two output and you wish that they were equal, the only way to make them equal is to have the same input. That is suggesting that it is not possible for different outputs to have the same input, or for different inputs to have the same output. So this is one-to-one, yeah? So this is 1-to-1 mapping, yeah, because it is one-to-one mapping, therefore it is injective, yeah, therefore injective. That's it. That's how you prove it. Okay, now this one probably a little more confusing. Surjective. Now to prove surjective is to prove that the range of y, right? So in a function we have a domain and range, right? So domain is the possible values of x. We already got the domain of this one. The domain of f here is given to be any real number except 0. It's just this one here. Any real number except 0, right? You got to know that. Okay, so that's just r except 0. But what is this thing? So this thing is called codomain. Okay, codomain is not the real domain, it's not the range either. So codomain is real number. Codomain is basically the expected outcome, the expected range that this function is meant to produce. It's not the real one, it's just the expected one. Now if it so happens that it's surjective, yeah, it is surjective when the actual range, which is Rf here, is going to be equal to the codomain, right? It's only surjective when this is true. Okay, so we're just going to prove the actual range. We're just going to find the actual range of this function to prove whether it's surjective or not, right? Now let's look at the function again. It's fx equals 1 plus 1 over x. You should also know about the graph anyway. So if I plot y equals 1 over x, you're going to get a rectangular hyperbola like that, right? But this is adding 1. So if you add 1, you're going to shift the thing upwards. If you didn't add 1, the asymptote will be the x and the y axis. But if you add 1, this is going to be shifted up by 1. This is going to go up by 1. And the asymptote will also be up by 1. So the asymptote is this guy, y equals 1. That is saying that this function, 1 plus 1 over x, cannot be 1, right? It cannot be 1. So now we got the range, because the range, or the y, or we write fx here, cannot be 1. Then that is not the same as the codomain. So this is one way to prove that it's not surjective. The other way is to play with the algebra. So we can say y equals 1 plus 1 over x. Well, if we make x the subject instead, I get y minus 1 equals 1 over x. I can switch between y minus 1 and x, so I get x equals 1 over y minus 1, like that. And clearly, y cannot be 1 either, because if it was 1, then x would be undefined. The denominator cannot be 0, so that's why y cannot be 1. And that's the same as plotting the graph. So fx is not equal to 1, not the same as codomain, right? So therefore we conclude that this is not surjective, right? Okay, so not surjective. And that would be how you do these two questions, okay? Right, and the other one, I think I overcomplicated it, is the integration. Yeah, so I'm gonna rub all of that, because I think I teased it a little bit first, that you can use subtraction method. Okay, so it would just be, because the normal volume of solid revolution would be integral y squared dx, right? But because this is just basically taking this area and revolve, I mean. So to revolve that, you need to subtract the whole area of this guy with this line. So basically it's just the curve subtracted by the line, the curve minus the line, and then you revolve. It's the same as the area I did in the other part, so it's the same as this, the technique is the same as this one, right? So it's just going to be pi times integral of y curve squared minus y line squared. and then dx. And now again, because we want to just do 1/2 here and multiply 2, so the limit would be just from 0 to whatever this is again. It was √6, right? So it's just going to be 2 pi, because we take 1/2 and multiply 2. So it's 0 to √6. And then y squared for the curve would be 8 minus x squared minus the line, which is 2 here, 2 squared, and then dx. So if we calculate that, we're going to get the answer, right? So 2 pi. So I'm just going to expand that again. So this will be 64 minus 16x squared plus x to the 4 minus 4. So I'm going to simplify that to 60 here. All right, dx. So that would be 2 pi. Yeah, I'm going to integrate now. So 60x minus 16 over 3x cubed plus x to the 5 over 5, 0 to √6. Yeah. So if we find the integral of that with the limits, we're going to get the answer. Yeah. So I think I'm going to use a calculator there. Yeah. So it's 2 times pi, brackets. So if we sub 0 in, everything disappears. So that's easy. So it's just going to be 60 √6. Okay. Minus 16 over 3 times √6, and then to the power of 3, yeah, and then plus fraction √6 to the power of 5 divided by 5. Yeah, so that should be it. 541.749 blah blah blah. So that's just 542 as the final answer there. Yeah. And I think everything else is fine. Yeah, I think I got everything. So I hope that was all useful. Again, guys, I would like you to support me by liking or subscribing. If there is enough demand by the number of subscribers I gain from this walkthrough, then I'll sure walk through more of this paper. I hope to see you in the next video. Bye.